DNA replication under the microscope. This is by King Abdullah University of Science and Technology. Cryogenic electron microscopy, cryo-EM for short, has enabled researchers to study how the DNA replication machinery assembles at sites where DNA is damaged. Cellular DNA is continuously exposed to both endogenous and exogenous DNA damaging agents, such as reactive oxygen species and UV radiation. To reduce the biological consequences of DNA damage, all living organisms have evolved mechanisms to tolerate and repair DNA damage to try to ensure that genetic information is accurately inherited, passed on to future generations. One such mechanism, called translesion synthesis, TLS for short, allows DNA replication to proceed through unrepaired DNA lesions. TLS involves highly accurate DNA synthesizing enzymes replicating DNA polymerases being temporarily replaced with specialized low-fidelity TLS polymerases that can ensure cell survival at the expense of introducing mutations. The mutagenic and translesion synthetic activity of TLS polymerases can result in normal cells becoming cancerous or cancer cells becoming drug-resistant. The Y family TLS polymerase POLK, is able to perform DNA synthesis across several damaged bases and is recruited to DNA lesions by proliferating cell nuclear antigen pCNA. Previous studies have shown that pCNA is regulated by ubiquitination. Quote, the addition of a single ubiquitin molecule at lysine residue 164, K164 of pCNA facilitates the recruitment and the retention of TLS polymerases to damaged sites, but the structural basis of the interaction between these polymerases and ubiquitination of pCNA is poorly understood, end quote, says structural biologist Alfredo de Biasio from KAUST. KAUST being the King Abdullah University. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. De Biasio's group has been collaborating with a laboratory led by Shamir Hamdan, an expert in single molecule analysis of human DNA replication, since 2018. They have been using cryo-EM to investigate the three-dimensional structure and function of key protein complexes involving DNA replication and repair. Their latest study describes cryo-EM reconstruction of full-length human POLK bound to DNA and incoming nucleotide and unmodified pCNA or monoubiquitinated pCNA at near atomic resolution. They found that in the absence of DNA, the structure of POLK bound to pCNA is highly flexible, suggesting that binding to DNA is required to form a rigid and complex activity. Mohammed Tessin, a senior researcher at Hamdan's group and the co-leader author of the study, performed key functional studies elucidating how pCNA ubiquitination modulates the activity of POLK. He said, our data provide a structural framework to explain how pCNA recruits a Y family TLS polymerase to sites of DNA damage. Tessin explains, because of the high degree of domain conservation between Y family polymerases, some of the structural features observed in the POLK DNA pCNA complex are likely to appear on other TLS polymerase complexes. And he concludes by understanding the interactions between the proteins forming these complexes and how they are regulated, we can identify ways to reduce or increase their function for medical applications. So you know where this is heading. This is heading towards applying this towards cancer therapy, I guess. This is by King Abdullah University of Science and Technology. by phys.org. Please leave your comments and thank you for your support.